For this video, let's try to evaluate this very complicated complex function. You have the limit of the product of 2z minus 3 and 4z plus I all over the square of iz minus 1 as z approaches I over 2. So we just need to apply here substitution process. You may of course would like to use the limit theorems, but you might add 1 or 2 or 3 more steps. So allow me to use the substitution process here because I believe that my denominator will no longer be equal to 0 as I use I over 2 as substitution or substitute for our z. So here we have the limit. Again, the product of 2z minus 3 and 4z plus I all over the square of iz minus 1 as z approaches I over 2. So this might need a lot of steps, so don't worry. Let's do it one by one. For our numerator, you have here 2 times your z is I over 2 minus 3. Second, let me use here brackets to differentiate the groupings. Okay, so let me use here bracket and bracket. For the second, you have 4. Your z is I over 2. You have plus I. And then you have here the close bracket all over your denominator. You have here I times I over 2 minus 1. Take note, you're squaring that. Okay, so that's the substitution. All the value or all z's were substituted by this value here. Let me continue. So the numerator, for the numerator rather, we can cancel this. Okay, that would mean we will be having I minus 3 alone for the first term. For the second term, take note you can do that as well here, but since it is 4, you still have 2 here. So that is actually 2i plus I. So basically, you're seeing some simpler forms now as you do it step by step. So basically, that's the process. Let's do it step by step. So for our denominator, you have over. Take note of this, you will have I squared over 2 minus 1, and you're squaring that. Take note, you are multiplying that, so your I times I, so I squared. Now, before we go to the next step, take note that there exists now I squared specifically in our denominator. Of course, the entire binomial expression would be squared, but since I squared is already provided here, and we know that it's equal to -1 because I is the square root of -1, we can just simply substitute here -1, making the entire denominator only real in its essence. Because this is how it would look like. The numerator, let's stick as it is. Of course, you can combine now 2i plus I, that's 3i. And your denominator will just be equivalent to -1 as your I squared over 2 minus 1 and squaring that. This is just specifically constant, or again, real in nature. That would mean your final form will have an answer which is no longer a rational expression because z or even the I is no longer present on our denominator. So if we're going to continue this, our numerator would you have here 3i squared and a minus 9i, right? As you distribute that one by one. Your denominator would be the square of -3 halves. So the numerator, take note, it also has I squared. And as mentioned, you will have your I squared here equal to -1. So you will have here 3 times -1 minus 9i, while your denominator would be the square of 3 halves. That's actually 9/4. Take note that you will have here, we'll use the keep change flip method because your denominator is a rational expression or a fraction in the form of 9/4. So allow me to continue this. Our numerator would be -3 minus 9i. This would be multiplied to 4 over 9. Our numerator can have factor of 3. So we have here 3 times -1 and minus 3i, and you will have here 4 over 9. So we're doing that because we can simplify this and that, leaving 3 in our denominator. So our final answer here is 4/3 as a whole times this. So you will have the answer here, 4/3 times -1 is -4/3. And by the way, if you're going to use 4/3 for the second term, you can also distribute, or factor, take that out here. So you will not be confused. Let's not cancel them in the meantime, because I would like to really show you their process here. So at the same time as well, let's not factor 3. You can of course do that, but allow me to do this so that my steps will not be confusing. So I have here -12/9, okay, and you have here minus 36 over 9 I, or again you can cancel that 9, but let me do it step by step. Here you will have your -3/4, 4/3, 4/3, and you have your minus 4i. Earlier we actually took out 3. We can cancel that by 3 here, but when I multiply the second term, I can even also factor, what they call this one, multiply that again, okay, or cancel that again. So the 3 will be removed there as you factor 3. So let me do it step by step in this manner so that we can actually just have the final cancellation or simplifying fractions at the end here. So this will be the result of this process involving the limit of this very complicated complex function as z approaches to I over 2. So just simply need to use all of this together with some concepts, just like I squared is just -1. Thank you very much for watching.